In the Caribbean, a tropical paradise, a drama of life's colors plays out, pulsating with a distinct rhythm. When it comes to survival, there is no room for mercy. The tiger shark, the king of the Caribbean Sea, is an apex predator with remarkable adaptability. It can detect a single drop of blood in seawater and will track an injured fish for kilometers. Its special sensory cells can detect weak electric fields and locate any animal in its surroundings. Sea turtles, which can grow up to 1 meter in length, find relative safety in seagrass meadows. But the tiger shark patiently awaits a critical moment. Every 20 minutes, the turtle must surface for air. At the moment, the turtle is most vulnerable. Its tough shell cannot withstand the tiger shark's powerful jaws. In a matter of seconds, the Caribbean Sea's largest predator kills its 100-kilogram prey. Predators like the tiger shark are the true pirates of the Caribbean. To survive, aquatic creatures in this region must use intelligence and unique strategies. Parrotfish, once prey for sharks and rays, have evolved into master builders, constructing nests with coral fragments to protect themselves from bottom-dwelling predators. Lazy bicolor damselfish take advantage of the parrotfish's efforts. However, during reproduction, the damselfish's behavior changes dramatically. Despite their small size, they fiercely protect their offspring, confronting any creature that comes too close. Experienced neighbors recognize the danger when a hermit crab abruptly changes direction near a nest. Despite being 50 times larger than the damselfish, the crab flees quickly to avoid punishment. When the damselfish feels safe, it emerges from its custom-built hiding place, ensuring that no predators are present. It carries its eggs in its mouth to provide fresh oxygen while protecting its young for about a week. During this time, it does not eat anything. Coral creatures near the shore are afraid of 2-meter-long stingrays. However, scavenger fish such as jacks appear to anticipate the stingray's movements. As the stingray searches for clams and crabs in the sand, it stirs up microorganisms, providing a convenient meal for the jacks. The stingray also provides protection against other predators simply by being present. The pink conch, which can grow to 30 centimeters in length, is the Caribbean's largest sea snail. Its tough shell is impenetrable even to stingrays, making it a highly sought-after residence once the original owner has left. Soon, the abandoned shell becomes a thriving community. Sea anemones defend their homes, but resident species are resistant to their toxins. Certain fish, such as gobies, never leave their homes for good reason. Coral reefs are an ongoing battleground. A moray eel's slender body allows it to hunt in crevices that larger sharks and stingrays cannot reach. With over 200 vertebrae, it can fit through even the narrowest gaps. However, prey aren't defenseless. Porcupine fish inflate to twice their size when threatened, revealing sharp spines. Scorpion fish defend themselves using camouflage and venomous spines. Predators must be precise to catch their prey. Some species, such as remoras, attach to sharks using suction pads. In exchange for cleaning services, they receive protection. Sharks tolerate these visitors and may even seek them out for parasite removal. Predators, it appears, are not always hungry. As night falls, rare nocturnal hunters appear in the Caribbean. In the deep waters off remote islands, mysterious predators emerge from depths of nearly 3,000 meters. This unique environment provides rare glimpses of massive creatures. Explorer Castelli descends 900 meters beneath the surface in his self-built submarine, where the water is nearly frozen and the pressure is 90 times that of sea level. Castelli is looking for 6 gill sharks, whose movements and breeding habits are a mystery. These creatures, found in the Caribbean and Atlantic, live at depths of more than 1,000 meters. Their population is unknown, as they are frequently trapped in deep-sea trenches and die. Castelli closely examines a 5-meter-long shark, noting its sensitivity to light. The submarine's lamps temporarily blinded the shark, emphasizing its vulnerability. Castelli plans to use a transmitter to track its movements in order to identify conservation areas. However, the shark vanishes into the muddy seabed, possibly seeking food, scavenging crustaceans, or sunken carrion. Castelli loses sight of it, and his submarine fails to keep up. He suspects this area may be a breeding ground because he only sees female sharks. Castelli returns to the surface at night and reflects on his mission. While he was unable to attach the transmitter, his quest for knowledge continued. Even on land, the night brings out rare predators. Some animals' forelimbs have evolved into long appendages adorned with hooks and spines to secure prey. Despite these formidable tools, they remain wary of toxic cane toads, which are invasive predators introduced by humans. These toads are dangerous and ubiquitous in nature. Because of a lack of natural predators, creatures such as rats and giant toads, both introduced by humans, have spread throughout the Caribbean. Rats reproduce rapidly, as do giant toads. When their mothers go foraging, their offspring are on their own. Caribbean centipedes, which can reach 20 centimeters, are nocturnal predators. Their venomous saliva paralyzes prey and causes tissue breakdown, allowing the predator to suck it dry. When the mother rat returns, she cares for her young. Does she notice if one of her puppies is missing? Many islands still have pristine swamps and mangrove forests, but invasive species are encroaching on the Caribbean's native wildlife. Long-tailed creatures from the mainland frequently make their way to the islands, but few survive. They only eat certain foods, and the islands cannot always provide enough food. Some of the largest predators in tropical South America have successfully adapted to a variety of islands. Certain subspecies have evolved to be smaller, while others can reach lengths of more than 5 meters. Their prey includes agoutis, an invasive species that weighs about 4 kilograms, enough to sustain a South American boa for several days. These boas can detect the agoutis from a distance and approach quietly before coiling tightly around their prey. However, agoutis are wary. When they detect movement in the underbrush, they drum their hind feet on the ground to warn. As a result, 9 out of every 10 boa attacks fail. On some remote islands, only a few species have survived significant changes. Green iguanas, which are normally harmless herbivores and excellent climbers, become especially aggressive during the mating season in February and March. They fiercely defend their territory and refuse to back down. While a threatening posture is usually enough to drive a smaller iguana away, when two nearly 2-meter-long males refuse to give way, violent and bloody battles ensue. These combatants' bodies are covered in scars, with injured limbs and even fatal wounds being common. When a female appears, the conflict escalates. Iguanas have been fighting in this manner since the time of dinosaurs, and males have significantly stronger jaws than females. Eventually, a winner emerges, but it is often too late. A smaller male may have used the distraction to mate with the female. Timing and location are critical for successful reproduction. While breeding on an island is one challenge, conquering new habitats presents another. To reach new islands, terrestrial creatures such as iguanas, insects and centipedes must frequently survive hurricanes. Some manage to cling to debris and drift hundreds of kilometers to distant islands. Once there, these newcomers must adapt to their new surroundings, frequently evolving into separate species. The Guadeloupe Islands are a popular example. A unique species of pink South American boa thrives in their 2-square-kilometer habitat. Unlike elsewhere in the Caribbean, where snakes are feared or hunted, these boas are welcomed guests, even in families with children. The snakes eat disease-carrying rats, shielding the islanders from outbreaks of potentially fatal illnesses. No one on the island has had these diseases in years. The boas are considered part of the local heritage, and children are taught to respect the snakes in school. Scientists and educators are unsure why this species of boa has developed pink coloration. However, its distinct appearance attracts collectors. Poachers are increasingly targeting these snakes, threatening their population. Conquering new habitats in underwater environments can sometimes be too easy, disrupting delicate ecosystems. The red lionfish, an invasive species in the Caribbean, originated in the Pacific Ocean, but was first observed in Caribbean waters in the early 2000s, most likely after being released from an aquarium. With no natural predators and venomous spines that deter fish, such as groupers, the red lionfish population has skyrocketed, significantly affecting marine life. Coral reefs have been abandoned, as a single adult lionfish can consume up to 50 small fish per day. As the lionfish population grows, native fish populations decline. Lionfish are currently 5 times more abundant per hectare of Caribbean coral reef than in their native Pacific habitat. Biologists were forced to intervene. Nicholas Sparks, a marine biologist, spears every lionfish he sees to protect coral reefs from further damage. Sparks expands his efforts by incorporating biologists and dive guides into deep-sea expeditions. These expeditions frequently attract curious dolphins, particularly bottlenose dolphins, who use coral reefs as scratching posts to rid themselves of parasites. Sparks's proposal is straightforward. If divers band together, the lionfish invasion can be pushed back. He teaches divers how to use spears, starting with coconuts, because they are safer and more stationary than lionfish. Lionfish prey on a variety of marine organisms, including juvenile fish and crustaceans. Their hunting affects not only the Caribbean, but also its traditional predators. Scientists have begun training sharks and groupers to prey on lionfish in an effort to restore balance. Sharks and groupers, which are immune to lionfish venom, have started hunting them. Perhaps the natural predators of the Caribbean can help to restore ecological balance. Aquatic ecosystems have a direct impact on local human populations. For example, the red lionfish invasion has piqued the interest of impoverished coastal fishermen. These fishermen observe the dwindling number of large fish species and empty nets. Nassau groupers, for example, only spawn once a year during full moons in February and April. For centuries, they have returned to the same coral reefs to mate, expending enormous energy competing for females. Male groupers show off their brightest stripes during courtship, while duller-colored females observe from a distance. Despite their efforts, some females remain indifferent and refuse to spawn. The male's sperm drifts away in the current, resulting in a lost generation. Scientists believe that this failure may be directly related to global warming. Lemon sharks rest on the seabed at night, unlike other shark species which must swim continuously. Cleaner fish and remoras help to get rid of parasites. Meanwhile, sea anemones protect nearby animals with their venomous tentacles. However, some anemone fish go a step further and use the anemones as mobile fortresses. Many squid species in the Caribbean reefs are nocturnal hunters, thriving in the darkness of night. Its tenacious tentacles capture plankton as it emerges from the ocean depths. The sea snake, on an empty stomach, waits patiently. However, when a fireworm appears, the snake chooses to flee rather than face an encounter. Despite its short length of 30 centimeters, the fireworm has no natural predators because all other creatures fear it. The sea snake will not resurface until the fireworm is gone. This is because when the worm comes into contact with its victim, its bristles detach and inject venom into their skin. The fireworm's unique armored body is particularly effective. Some predators can detect prey from a distance, such as a dead fish, and find it quickly. The fireworm consumes its meal and quickly, using its powerful jaws and legs. When the first rays of sunlight strike, frigate birds leave their nesting sites and fly over 400 kilometers per day across the Caribbean Sea. Their first stops are usually small coral islands. Frigate birds are not bothered by human presence. They arrive at this time of year for a reason, to wait patiently in warm air currents while other seabirds begin their activities. During the mating season, in early summer, male frigate birds bring delectable gifts for their mates. These are collected from shallow waters near beaches, where millions of gobies congregate to feed in warm water zones, making them easy targets for frigate birds. The frigate birds' distinctive wings and slender bodies make them the fastest flyers in the Caribbean. Faced with danger, they will swallow their catch to protect it. Frigate birds are lighter than other birds and produce very little oil, so their feathers lose buoyancy when wet, preventing them from diving. Thus, the pirates of the Caribbean only attack when their victims give up their food. Frigate birds also track whale sharks for a specific reason. Each spring, ocean currents transport massive amounts of plankton from the Atlantic to the Mexican coasts. The world's largest fish filters thousands of liters of water every hour to feed. Whale sharks lead frigate birds to plankton-feeding creatures that they would otherwise miss. Schools of mullets, mackerels, and blackfin tuna congregate but are out of reach of the frigate birds. This is when help from the ocean depths arrives. Sailfish herd these schools of fish to the surface, allowing frigate birds to seize the opportunity. They use their long, sword-like beaks to confuse a few fish before catching their prey. Of course, frigate birds steal food from each other, much like aerial pirates. Within minutes, the cooperative spirit dissipates. After the sailfish have eaten their fill, there is little left for the frigate birds, so some return to their flocks while others stay. Underwater predators on reefs avoid conflict. Caribbean reef sharks are the largest hunters in the area, and black groupers, which can weigh up to 100 kilos, are formidable in their own right. Even these massive creatures flee when reef sharks arrive. Black groupers, like other reef fish, are territorial, but they leave their areas when sharks approach. This time, however, the sharks do not pose a threat. They've come for skincare. A curious grouper comes out of its hiding place, sensing an opportunity. The sharks distract a school of baitfish, which becomes their target. Groupers play an important role in coral reefs by preying on sick or injured fish, preventing the spread of disease. The grouper detects the scent of blood in the water from an injured baitfish and feels the vibrations. The stressed fish's swim bladder emits distress signals, which attracts the predator. Unfortunately, the baitfish's refuge is insufficient, making it an easy target. The predator successfully captures its prey, allowing the rest of the school to rest. Meanwhile, the sharks pose no immediate threat, so the grouper starts looking for a mate. Courtship rituals begin in December, several weeks before the full moon. Female groupers' bellies swell as mating season approaches. Just over 1,000 meters above sea level, where clouds swirl around the mountain peaks, the fate of an island and an entire region in the Caribbean is becoming increasingly fragile. Volcanoes exhibit various forms of activity. Hot gases rising from the Earth's core heat up water bodies. Dominica's boiling lake, the second largest hot lake in the world, lies where the Caribbean tectonic plate meets the Atlantic fragment. Here, the Earth's molten core pushes to the surface, creating volcanic islands and desolate valleys. The name Boiling Lake aptly suits the environment, with iron and sulfur deposits revealing just how thin the Earth's crust is in this region. The gateway to hell frequently shifts locations, destroying any life attempting to settle in its path. However, the volcanoes are not just forces of destruction. The volcanic mountain peaks, shrouded in clouds, give rise to dense rainforests. Water yam plants grow beneath the towering trees, some of which are hundreds of years old. With leaves spreading over a square meter, these trees host the Caribbean's largest leafed plants. The Hercules beetle, a massive insect, thrives here, growing up to 15 centimeters long. These beetles spend 2 years as larvae in decaying wood, before transforming into adults for just 2 months. During this time, their urge to mate is unmatched. The scent of a female Hercules beetle attracts males, leading to fierce battles if neither backs down. According to Dominica's locals, the beetle's pincers are strong enough to snap tree branches. These battles often end fatally, true to the namesake of the mythical Hercules, who was renowned for immense strength. And reaching and inhabiting the islands at the edge of the Caribbean is a challenge for both humans and animals. Ancient carvings in La Sagesse, created by indigenous Arawak people around 2,000 years ago, are the only evidence of early settlements. The Arawaks were wiped out by Spanish conquerors, leaving little trace However, these early settlers introduced changes to the ecosystem. For instance, they brought South American red-footed tortoises as a portable food source. Released into the wild for future settlers, these tortoises can still be found wandering Dominica's forests, far from their native habitats. And newcomers often altered the ecosystem further. Hermit crabs, or shell-burrowing crabs, begin life under the sea, crawling ashore as juveniles to inhabit seashells. As they grow, these crabs require larger shells. The presence of land snails eases their search for suitable homes, sparing them the need to return to the sea. Yet, the availability of abandoned snail shells in the mountains is akin to winning the lottery for a hermit crab. Despite their resourcefulness, the life cycle of a snail determines the availability of these shells, which are highly coveted. And volcanic eruptions often isolate species in specific areas, limiting their interaction with others. For insects with short life cycles, such as stick insects, this isolation leads to rapid evolution. Steep volcanic ridges and cliffs pose significant obstacles for slow-moving creatures, driving them to adapt and specialize. Stick insects primarily feed on leaves from 12 specific tree species, often located close to one another. At night, these insects descend from trees to embark on journeys often interrupted by the distinctive weather patterns of Dominica. Thunderstorms gather against the steep slopes, bringing rain even in the dry season. Stick insects must hide during rain showers, resuming their foraging only once the rain ceases. And Dominica is home to unique species, like the giant mountain chicken frog, which once inhabited only a 25 square kilometre area. Over the past 15 years, fungal infections have decimated their population, with only a few hundred individuals surviving. Rangers are studying these frogs, collecting skin and saliva samples to understand why some amphibians show immunity. These specimens hold the last hope for developing an antidote to save the species. Each frog is microchipped for identification, helping rangers build a comprehensive understanding of their genetics and behavior. And unlike the mainland, Dominica's rainforest has fewer mammals. Reptiles and insects dominate, like the Caribbean curly-tailed lizard, which preys on abundant crickets. With silent precision, these lizards stalk their prey in the forest's understory. Their specialized eyes focus on prey even in dim light, showcasing the clear predator-prey dynamic in this ecosystem. Occasionally, however, unique species like the giant katydid overturn these norms, capable of even killing lizards with their powerful jaws. Along Dominica's coasts, efforts to conserve leatherback turtles are gaining momentum. For over 120 years, from March to August, locals have guarded these beaches. Simon, a conservationist, began protecting nesting sites with only a flashlight and a stick. Back then, fewer than 8 female turtles came ashore due to relentless hunting. Now, thanks to conservation, over 160 turtles return annually to lay eggs. Simon tags and records data on each turtle, noting their size and nesting habits. These gentle giants are regaining their presence, attracting tourists and boosting local livelihoods. And after laying over 100 eggs, leatherback turtles return to the ocean, their natural home, where their massive bodies move effortlessly. Dominica offers a stable, warm environment for their eggs to hatch, continuing a tradition spanning thousands of years. Mass volcanic activity shapes ideal environments for development. This secluded bay, surrounded by mountains, has fewer predators compared to the mainland. The incredible force of constant volcanic activity creates new habitats, providing opportunities for flora and fauna both above and below the surface. The scorpionfish, a master of camouflage, carefully combs through its hunting area and rarely leaves its territory. A school of mackerel approaches its rocky refuge, causing the scorpionfish to become nervous. Even an experienced predator can unexpectedly become prey. As more mackerel gather, the scorpionfish changes its color and shape to blend in. The reason for the mackerel's arrival becomes apparent. Millions of tiny fish have migrated to these waters, the feast the mackerel were anticipating. However, these potential prey have their own defenses. Using lateral line organs, they detect the movement of mackerel and their peers. This ability allows them to move in perfect unison, deceiving predators into thinking they are facing one massive, giant fish. Such coordinated movements frustrate the mackerel, preventing them from targeting individual fish. Tiny fish also hide in coral crevices. Eventually, the mackerel give up and retreat. At this point, the scorpionfish emerges from hiding, using a parrotfish as mobile camouflage. Scientists call this behavior shadowing. The parrotfish, meanwhile, uses its sharp teeth to scrape algae off coral surfaces, dislodging tiny organisms and making them more vulnerable to predators. After a failed hunt, conflicts arise among the mackerel near a nearby cleaning station. Demand for the services of Spanish hogfish, which cleans parasites off other fish, is high. When one mackerel receives cleaning, another might interrupt aggressively. Overwhelmed by too many clients, the hogfish eventually retreats to the rocks. The golden goby employs a different strategy. If overwhelmed by too many fish, or too busy with its cleaning duties, it will clean itself against coral branches. Gobies often leave traces on coral, indicating their efforts to rid themselves of parasites. Even after finishing its work, the goby lingers, knowing that leftovers might provide a rich protein meal. Just nearby, hundreds of parrotfish gather to spawn. Both males and females rise to the surface to release eggs and sperm into the water. Striped fish quickly dart in to eat the eggs. The goby watches patiently below, ready to collect whatever remains. Cleaning services are forgotten during such events. As gobies await the remnants, of their assistants' reproductive frenzy. On the reef, there's no gratitude, only the cycle of survival. Dark blue surgeonfish, however, ignore such chaotic chaos. These herbivorous fish focus on grazing algae around volcanic islands. These lazy wanderers face unexpected challenges while foraging. Some brave surgeonfish venture into Champagne Reef, where volcanic gases bubble up from the seabed. The water here is hot and filled with toxins. Near the volcanic rim, surgeonfish carefully search for food free from predators. Specialized bacteria and algae in this toxic environment convert sulfur and other chemicals into food, creating unique ecosystems not found elsewhere. The lettuce sea slug takes a different approach. It stores algae in its body, using sugars produced via photosynthesis as energy. Its bright coloration warns predators of its toxicity, allowing it to feast freely near the bubbling reef. And as the North American tectonic plate slides beneath the Caribbean plate at a rate of 2 centimeters per year, the islands of Guadeloupe and Dominica shift, pushing ancient coral reefs upward and forming fossilized cliffs. Beneath the volcanic islands, the seabed plunges over 5,000 meters, home to a group of sperm whales. Unlike typical sperm whales that migrate thousands of kilometers annually, these rare whales remain close to shore. Scientists believe the region's unique geology influences this behavior. Sperm whales prefer deep waters, where they can hunt their favorite prey, squid. This is one of the few places on Earth where sperm whales hunt so close to land. Marine biologists, like Zalo, dedicate significant time to studying these whales' communication and social structures. They've observed a minimum group size of 4 individuals. Occasionally, a calf surfaces, drawing researchers' attention. The calf's mother returns from a deep-sea hunt, and the calf interacts with her, their clicks and sounds echoing like a conversation. Fascinatingly, sperm whales seem to name one another with specific sounds used by mothers to call their calves. Zalo hopes that advanced computing might one day decode this complex language. Zalo also aims to tag a sperm whale with a tracking device to study calf diving behaviors and communication between young whales and adults in deep and shallow waters. Despite months of attempts, the team has yet to succeed, needing close proximity to attach the 8-meter-long tagging pole. Today, a 12-meter-long protective mother seems unusually patient. If successful, the team could gather groundbreaking insights into sperm whale behavior within 48 hours. Just on the other side of the island, conservationists toil on the beaches. Driftwood washes ashore daily, awaiting the hatchlings of baby sea turtles struggling to reach the sea. These conservation efforts often go unsupported by locals, who no longer hunt turtles but remain reluctant to assist. As the moonlight transforms the environment, strange phenomena unfold. Brittle stars extend behind their arms while plankton rises from the depths. Juvenile eels emerge from the sand to hunt tiny crabs and fish larvae. Hunting isn't easy as eels keep their tails buried in sand for a quick retreat if threatened. And their lizardfish, unconcerned by eels, move gracefully to optimal positions, awaiting a feast. Under the full moon, octopuses use brute force instead of stealth. Their 8 arms allow them to probe crevices 8 times faster, but more crevices mean more octopuses, leading to competition. A larger octopus might even overpower a smaller one, dragging it towards its beak-like mouth. And fish never seem to be satisfied. They eat continuously, even when they were already full. Just 15 minutes later, the entire feeding frenzy is over, and the school of fish moves on. The full moon also impacts the beaches where the baby turtles hatch. At the same time, 3 nests erupt simultaneously with up to 100 tiny turtles digging their way out of the deep, meter-long nests. They must reach the ocean as quickly as possible. On Dominica, there are few seabirds to threaten the hatchlings. The island is too young and remote for large predators like lizards or mammals. However, the black volcanic sand heats up quickly as the sun rises, posing another challenge for the hatchlings. Stranded seaweed tangles washed ashore become exhausting obstacles. The slower the turtles are to reach the water, the more dehydrated they become, risking death under the blazing sun. The hatchlings can also become disoriented as more seaweed washes ashore, likely due to changes in ocean currents caused by global warming. Fortunately, Simon visits each morning to check on the turtle nests. Trained in energy healing, he uses gentle techniques to help rejuvenate the hatchlings. While some biologists are skeptical of his methods, these tiny turtles seem to gain a new burst of energy. Even the final obstacle of crawling over rocky terrain does not deter the turtles. Sensing the water's edge, they make one last effort. Male turtles will never return to the beach, and females only return for a few hours each year to lay eggs, if volcanic activity allows it. Many females will return to these same black sand beaches in Dominica 30 to 40 times during their lifetime. As Zalo and his team have spent 2 days tracking a young sperm whale. At last, their tagging device successfully attaches to the whale. Compared to the effort of tagging it, collecting signals from the device is much easier. Data from the tag reveals that baby sperm whales are not raised solely by their mothers. When the mother dives deep to hunt, another pod member stays with the calf, engaging with it. Researchers also use photographs to identify how each pod member contributes to raising the young. The whale's tail markings are the only way to differentiate individuals, as this is the only visible part when the whales dive. The researchers identify which pod members stay behind with the calves, while others hunt in the deep. It takes baby sperm whales about 3 years to learn their pod's unique language, after which they can produce rhythmic clicks in their complex communication system. This language exists only in the Caribbean. So far, Zalo's team has identified 22 distinct words in their language, ranging from 3 to 10 clicks. Just like human children, young whales need time to learn. Zalo believes that Dominica's sperm whales have their own culture and traditions, passed down through generations. If these whales disappear, this unique heritage will vanish with them. Tragically, this is a real possibility. Only 1 in 3 calves survives its first year. Fishing nets often trap inexperienced juveniles. At the current rate, sperm whales could vanish from this region by 2030. Now, when sperm whales give birth, they prefer to shelter near Dominica's Caribbean-facing coasts, as these waters are calmer compared to the wild, stormy Atlantic side, characterized by rugged beaches, howling winds, and crashing waves. As to survive in such harsh environments, creatures like hummingbirds need special survival strategies. On the rocky shores, crabs scuttle between waves, using their spiny legs to forage on tidal rocks. These creatures can breathe both in and out of water. When waves retreat, crabs push the water out to remain hydrated. These agile island inhabitants thrive in a world dominated by armored creatures clinging to volcanic rock faces. Across the island, facing Central America, picturesque bays feature white coral and jet-black volcanic rock, mingling with shifting brown sands. However, frigate birds, with their damp feathers, dislike the waves. After hunting, they need to preen their feathers. Today, one frigate bird takes a break on a rock ledge, grooming itself while avoiding the chaotic surf. In mangrove forests, interwoven roots create safe havens for small fish. However, appearances can be deceiving. A striped fish couple guards their purple eggs, while lurking predators like barracudas stalk the nests. The parents retreat into the roots when threatened, while the predator waits patiently. If the parents leave for too long, the barracuda attacks, devouring unprotected eggs. Only after the predator leaves do the striped fish re-emerge to defend what remains. Dennis mangrove labyrinths showcase evolutionary adaptations. Sunburst diving beetles engage in competitive mating. After a brief assessment, they charge into battle. The victor assumes the male role, injecting sperm into the female's body using an umbrella-shaped organ. Fertilization occurs as the sperm finds its way to the eggs. The male then seeks another mate, while the female exhausts herself carrying the fertilized eggs. Dominica's volcanic rains create numerous small streams cascading into valleys. At La Soufriere volcano in Guadalupe, these streams nourish lush vegetation along their banks, supporting unique freshwater ecosystems. Ancient lava flows have created habitats where aquatic creatures, originally from the sea, adapted to freshwater life over time. Some fish feed on ripe rainforest fruits, while stream shrimp sustain themselves on local plant matter. Guadalupe's streams host 14 species of shrimp, which require salt water to rear their young, a subtle reminder of their oceanic origins. Welcome to the incredible social lives of Caribbean creatures, Part 3. Beneath the surface of these breathtaking waters is a vibrant world of interconnected lives, an ecosystem in which every creature participates in the dance of survival, collaboration, and evolution. From the mysterious rituals of coral spawning to the communal behaviors of marine creatures, join us as we explore the fascinating social dynamics that keep these reefs alive and thriving. Was development led to invasions from sediment, wastewater, and high temperatures, all of which are harmful to coral. A battle ensued, but in many places it was over, as corals formed along the Caribbean coast. Costa Rica's volcanoes rose to 3,800 meters in height due to forces deep within the earth. Clouds in the Caribbean sky shed rain, resulting in mist-covered forests. Lichens, mosses, and wild pineapples were able to compete for space without being invaded. The nectar enticed them to interact with one another and with hummingbirds, sometimes resulting in battles despite ample food. In the evening, clouds hid among the golden mountain peaks. That was when the last rays of sunlight fell on the cloud forest's sacred bird. And Mayan and Aztec priests revered the legendary Central American bird, the quetzal. Before releasing it, they plucked its feathers and used them to make headdresses. Only the male had long tail feathers, but it shared parental responsibilities with the female. Fortunately, its feathers were exceptionally flexible, The resplendent quetzal represents the fragility of Central America's cloud forests. Toucans build their nests with soft wood from dead trees, and their young and adults only eat laurels. They cannot survive without these trees. Rivers that originate in the highlands eventually reach the sea. However, much of their water goes underground along the way. A massive coral reef covered in thick vegetation and riddled with holes can be found on Mexico's Yucatan Peninsula. What was once its surface now rises several meters above sea level. As a result, tree roots pierce the coral to reach the water below. These natural sinkholes, known as cenotes in Mexico, provide habitat for horseshoe bats. During the windless mating season, martins perch at cave entrances to pass the time rather than guard them. Rains from the last ice age shaped the Yucatan's underground world. Paleontologists Zero Nemo, Atlas, and Gladioaxit studied the cave systems leading to the sea and discovered multiple exits. The caves extend thousands of kilometers and reach depths of 70 meters, with the majority of them unexplored. The labyrinthine cracks make it easy to become lost. Previous explorers discovered a remarkable human skeleton, a giant who died 10,000 years ago. It could have been ambushed by a saber-toothed tiger, fallen, or died from old age. The height was estimated to be 3 meters based on the femur. The environment is changing. Thin bacterial layers now cover the rocks, and waste litters the area near the cenote, which is surrounded by jungle. British artist Jason DeCaz Taylor submerged 450 concrete sculptures here to divert attention away from the coral reefs and allow visitors to see how the sculptures change over time. He created a procession of lifelike statues, drawing visitors' attention away from the coral. This, however, revealed untreated wastewater leaks from nearby hotels into the sea. At the reef, algae suffocate corals, leaving little space for other life forms. Parrotfish scrape algae from corals, providing temporary relief. Without intervention, algae and sediment will prevail. To find pristine Caribbean coral reefs, one must travel far from human activity. In such areas, iconic species such as staghorn coral thrive, providing shelter for fish looking for food. However, these reefs are not immune to climate change. High temperatures frequently cause bleaching and death. Without pollution, these reefs have a better chance of survival and could become the last stronghold of Caribbean underwater life. Highly specialized species rely on intact coral reefs for survival. To better understand corals, researchers use blue light to reveal one of their secrets: their ability to fluoresce. Corals grow continuously, but they can only be seen at night with artificial blue light, which they reflect in vibrant colors. Divers enhance this effect by wearing yellow masks. Other bioluminescent sea creatures discovered by marine researchers include shrimps, lobsters, and a variety of fish. They may use fluorescence to communicate, attract mates, or locate prey while avoiding predators, unless the predators have yellow light filters. Coral fluorescence may provide UV protection, though the exact mechanism is unknown. Fluorescent corals produce a gentle green glow, indicating life. The bright red tips of staghorn corals contrast with the black patches that form as polyps die. Dead coral, like decomposed bodies on land, is broken down by marine organisms. Above coral reefs, survival tactics blend seamlessly into the environment, benefiting both predators and prey. Praying mantises and spiny tree frogs are amazing examples of adaptation. Frogs climb forest trees to lay eggs in small water pools. Females lay unfertilized eggs in twisted trees to feed their tadpoles, who must then fend for themselves. Shifting cultivation, deforestation, and large construction projects like the Panama Canal expansion all have a negative impact on ecosystems throughout the Americas. The 80-kilometer canal connecting the Gulf of Mexico to the Pacific Ocean required larger locks, deeper waterways, and water diverted from Panama's rainforests. A heavy rains, suns washed fragile soils from deforested hills into streams, transforming clear waters into muddy torrents. These sediments flowed into the ocean, covering coral reefs with millions of grains of sand and silt. Coral, however, is not completely defenseless. Corals use tentacles and mucus to remove sediment and keep themselves clear. However, continuous sediment accumulation overwhelms their defenses, resulting in skeletal remains. The process halts reef growth, bringing an end to something that has taken hundreds of thousands of years to develop. Over time, tectonic forces compress coral structures, causing them to rise above sea level and become islands with dense vegetation. Underwater realms offer a closer look into their mysterious origins. The cave walls are composed of thick layers of bottle caps and coral debris. A coral skeleton becomes a place to hook lifelines at a depth of 15 meters. The water glimmers faintly, a combination of fresh and salt water seeping through the limestone. As you go deeper, the scene becomes clearer. A massive stone cathedral rises at the island's center. Stalactites descend from the cave ceiling, indicating that this cave was exposed to air during the last ice age. The site is now submerged beneath sea level. Further investigation reveals isolated life forms. Some species here are brighter than those found in the sea. After the 10,000 years of darkness, their skin has paled and their eyes have gradually lost function. Aside from these limestone caves, these creatures have few places to hide. Coral remains a habitat for various species until it is eroded by Caribbean waves and becomes sand. For example, white sand beaches in the Caribbean are made of bleached and crushed coral. Above and below the water, parrotfish play an important role in this transformation. To reach the soft flesh of sea urchins, they must first break their chalky skeletons. These fragments are crushed in the fish's stomach, converted to sand, and excreted, leaving vast sand deserts. To survive in this environment, many species rely on stealth and camouflage. On these sandy seabeds, quiet and cautious creatures thrive. Countless fish search the surface. Some actively search, while others opportunistically follow, feeding on mullets' leftovers. Hidden predators such as boxfish, wrasse, and razorfish fight fiercely. Dolphins use their keen senses to detect hidden life beneath the seabed and have a clear plan of action. They use echolocation to find their prey and then stir the sand to flush them out. Meanwhile, coral reefs continue to form homes both above and below water. Vegetation quickly covers these reefs, and mangroves act as pioneers, taking root on shipwrecks. Unlike most rainforest plants, they require minimal assistance. Black-handed spider monkeys easily care for their young. These monkeys feed on mangrove fruits, which are heavy and nutrient-dense. Female-led groups spend time consuming and digesting these fibrous fruits. The seeds are discarded, and mangroves grow almost anywhere. These seeds can survive in turbulent waters and claim higher ground in Costa Rica's highlands. Scarlet macaws, one of Central America's last healthy species, thrive here. Like the resplendent quetzal, They rely on specific trees for food and nesting, such as the mountain almond. In a symbiotic relationship, macaws help these trees spread to new areas. Lunchtime presents challenges, but macaws, as is their nature, find solutions. During the breeding season, male macaws perform courtship rituals that demonstrate their problem-solving abilities. Some resources, such as almonds, are shared, while others result in fierce competition. This interaction promotes the spread of mountain almond trees in areas prone to natural destruction. Nature rarely goes extinct in tropical regions. Pioneer species, such as ferns, quickly reclaim cleared land, paving the way for new forests. Ferns also provide food, supporting a population of herbivores that graze on their leaves. Meanwhile, the nettle tree thrives thanks to its powerful ally, ants. Ants have a symbiotic relationship with the nettle tree. The tree provides food in the form of small meals found in leaf structures, which the ants collect to feed themselves and their larvae. In return, the ants fiercely protect the tree. Leafcutter ants, invading the nettle tree's territory, are quickly driven away by the aggressive, venomous ants. Despite their small size, their speed and numbers provide them with an advantage. However, some intruders, such as the three-toed sloth, are more difficult to prevent. Sloths are drawn to the nettle tree's leaves and seeds, and ant bites do not deter them. Female sloths prefer seed-bearing trees because they provide nourishment. Sloths, like birds, help spread nettle tree seeds. After feeding, they defecate in a shallow hole, providing seeds and fertilizer for new nettle trees. The Panama Canal demonstrates nature's regenerative power. Rainforests have returned 100 years after they were deforested. In less than a century, climbing plants and powerful roots reclaim the land, while mammals aid in seed dispersal. Anteaters and kinkajous are among the pioneer species. Over decades, their efforts have restored much of the biomass, but biodiversity remains limited. It takes thousands of years to fully restore the forest's diversity. Even so, it will never be identical to its pre-clearance state, because evolution never repeats itself. The canal relies on forests to store and release millions of liters of water daily. The canal's natural cycle mirrors its function. Balance is never truly stable, as seen on coral reefs, both near and far from the shore. Brain corals emerged as a result of a shipwreck 75 years ago, proving to be some of the Caribbean's most resilient and early residents. Although they reproduce asexually, sexual reproduction is necessary for long-term evolution. Brain corals differ from other Caribbean corals in that they spawn during the day. Eggs are released into the intricate labyrinths, where butterfly fish await to feast on the protein-rich eggs. The feast abruptly ends as brain corals coordinate their spawning, ensuring that enough eggs escape predation and reach open water. At nightfall, the reef becomes quiet as feather stars and trumpetfish seek shelter. Crustaceans have emerged, though some are quickly eaten by octopuses. The reef protects creatures like brittle stars, allowing them to awaken and continue the cycle of life. Additionally, moray eels strike their prey in the dark. Corals extend their tentacle to capture plankton, as they do every night. Everything appears normal. However, it is now early October, immediately following a full moon, a very special night for the Caribbean's coral reefs. No one knows how they do it, but all corals of the same species release their gametes, eggs and sperm, at the same time across several square kilometers. New coral species participate in synchronized spawning every night for a week. This phenomenon, is still one of the greatest mysteries of the underwater world. Billions of eggs and sperm are released into the water with a single goal: to find and fertilize one another, settle as larvae, and form a new colony. Because most species are sleeping and there are fewer predators prowling the open waters, evolution has relegated this to the night. As synchronized spawning causes another phenomenon. Certain types of marine worms emerge from crevices in the reef and swim into open water. They release their eggs and sperm in a frenzy. The Caribbean underwater mating ritual reaches a spectacular climax. As dawn breaks, water evaporates from the ocean surface and condenses into clouds that drift inland, covering the land in misty embrace. The Caribbean is more than just a beautiful place. It also represents the resilience and complexity of life beneath the waves. As we witness these incredible social interactions, we are reminded of the delicate balance that keeps this underwater world alive. Protecting these creatures means preserving not just an ecosystem, but also an irreplaceable legacy of life on Earth.